Welcome back, folks, to the Get a Grip on Lighting podcast. On today's show, we have Dr. John Davenport from energyfocus.com. That's right. They're one of the leaders, Greg, in LED tube technology. He came on the show to tell us about emergency LED tubes. You've had some experience with this,
today,
Greg.
I have, yeah. Today, the specific item we want to highlight is the red cap emergency battery backup tube. So it's a Type B LED tube that has emergency capability in it. Why do you need that? Because if you are retrofitting a facility from fluorescent fixtures that have a ballast and you want to go Type B where you want to bypass the ballast and they have emergency battery backup ballast in them, you cannot go with a standard Type B tube. It won't work. Your system is not emergency backup anymore. This is a Type B tube that works like a Type B tube, but then if a emergency situation happens where you need the lighting, it kicks on. So the best solution I've seen for lighting retrofit when you're doing Type B, it's UL listed. It's the first one. We talk about that on the show today, how important that is. Patented, 150 lumens per watt, and it costs a lot less than having to buy new fluorescent emergency ballast and lamps. It's a lot cheaper to just go with this route. And I think it's one of the most unique, best solutions I've seen in the retrofit market in a long time.
Yeah, and you know what? If you're in the business of, if you're in the past, you've done a couple mistakes, like maybe you've taken a customer from compliance to non-compliance in the retrofit. I've never done that, Greg. Have you ever done that? No, we've all done that once or twice.
No, never.
And you end up like, holy mackerel, what happened? What did we do? And you got to go back and fix it. This is an excellent way to plug the hole there too. But you know what? Maybe just start by thinking about it from the beginning. Check out their emergency lighting. Go to energyfocus.com, or you can just Google Energy Focus Red Cap, and they'll take you right to the page where they talk about these emergency backup tubes, battery powered, awesome technology. And of course, John Davenport, he's always a pleasure to have on. Great guy. How many patents does the guy have, Greg? I don't even know.
I think it was in the other show, if you want to go back to that one, number 30 something, but yeah.
He's got dozens of patents. Okay.
Yeah.
And of course, the National Association of Innovative Lighting Distributors, our club. It can be your club too. Go to naild.org. That's nailed.org. Ooh, yeah. Go there. Check us out. But for right now, Dr. John Davenport on the Get a Grip on Lighting podcast. Welcome back, Dr. John Davenport from Energy Focus.
It's great to be back. It's great to see you guys.
Great to see you as well. Say hello to Greg Eric.
Hi, Greg. Good to see you. Good to see you at Light Fair. Okay, great.
Yeah, you as well. Thanks for being on again. Definitely.
Right.
So, John, tell us a little bit about what's going on at Energy Focus and what you wanted to tell us about in terms of the health effects of lighting.
Well, there's a lot going on at Energy Focus. As you probably know, we're kind of leading the charge in low flicker lighting, and I talked about that last time in detail. I think it's really important that flicker be eliminated, basically. And there are a lot of complex metrics. We now have quite a few folks talking about it. The DLC is talking about flicker reduction, but the simplest one, in other words, the flicker percentage, the flicker modulation, how much it varies, is really all you really need if it's low enough. Because if it's close enough to zero, it really doesn't matter what the frequency spectrum is. None of this other stuff matters. It's very simple. And in fact, it's quite possible to get that number below 1%. And in fact, we're less than 0.5%. The UL is certifying us on this, and their measurement basically can't go below 1%. So that's at the detectable level, and that's something that is entirely doable and should be done across LED lighting. There's no reason not to.
When I'm discussing projects with my people, I often tell them like don't make the perfect the enemy of the good, or the good enough. Mm-hmm. Is that what you're talking about there? Like a little bit of flicker, a slight less than 1%, is virtually harmless to everybody. Is that what you're saying?
Right. It's basically it's not detectable by instruments and by people. And the IEEE would back that up. They've done a great deal of work on this. There was a commission that did this, and if you look at the results, that's what they would basically predict as a level that would be absolutely safe, and it's doable. So why not just do it? It's kind of like CRI, right? In color, why wouldn't you have color that rendered objects similar to the color you see in daylight and on incandescent lamps? Why would you have them look like high pressure sodium lamps when now you can with modern LED technology get really good color lamps? So that's another area that of course we're working in. We're working in understanding the spectrum and creating products that promote health and wellness, and that's something you can do very positively with LEDs. One of the products that or technologies that I am excited about actually is a kind of an enabling technology, and that is this area of emergency lighting. This has been a real problem for LEDs because retrofitting out fluorescence and putting in and being able to follow the code requirements for egress lighting, emergency lighting in the case of a power failure, has been problematical. And there haven't been any good solutions until relatively recently. And that is pretty exciting. I think that's very exciting. It's now possible to package the emergency lighting and a regular light LED lamp in the same tube and basically just plug it in. An utterly simple solution to a really difficult problem. And the reason you can do it is that LEDs now are so efficient that the energy storage requirement is low enough that you can get rechargeable batteries inside the tube along with the LEDs and the other electronics. And you can get really high performance out of these things.
Now, one of the areas that we haven't had a good discussion with, and that's what we're going to talk some today, is emergency lighting and trying to get a better understanding of it all. So you said to code. Is code universal? Every non-residential building in the U.S. and Canada need to have X amount of foot candles at the emergency level? Can you dive into that?
Yeah, they do. Okay. The codes vary somewhat. European codes are different from US. So let's focus on the US. In the US, normally, there is a minimum lighting level requirement for the path of egress. In other words, how do you get out of the building with the lights out at night, okay, and not fall down? And so it lights that trail, so to speak. That number is greater than 1 foot candle, and you'll find it in lots of different places. National fire protection codes, for example, there are international codes, and they're all about the same lighting level. The other thing that's important is how long. How long do you need to be to have this capability? And UL has a standard, UL 924, which specifies greater than 90 minutes. So you have to have a time that the light is available for more than an hour and a half. And the idea is that gives folks enough time to get out of the building and to, if there's a fire, for example, and that should be plenty of time to do that. The other thing that the codes do is talk about the safety of the product that you're putting in. There are really 2 ways of doing this. You can have a backup generator kick in, and hospitals, for example, may have that. And some other emergency rooms, for example, hospitals have that. Or you can have the energy storage locally in rechargeable batteries. And everybody is seeing these bug eyes in buildings. And the idea of the bug eye is to actually provide this function. There's a real problem with bug eyes, though. They're usually not very good and not very well maintained. So that, I don't know about your buildings, but every now and then in Solon, Ohio, we would have a lightning strike and the lights would go out and not all of the bug eyes would be working. Maybe,
see, I don't see that as a problem.
Yep.
I don't see it as a problem. I see it as a wonderful opportunity to make a killing.
It is. It's great.
What problem? What's the problem?
For the people in the space, Mike, there's a problem. They can't
okay.
Not you.
No, that's exactly right. So we saw it as an opportunity, and others have seen it as opportunity. And this is a category that I think you're going to see grow rapidly. The opportunity is to get in something that really works a whole lot better without the complications that fluorescent battery backups have. You know, there's like a maze of wires these things have. You have to have a PhD in order to figure out how to put the thing in. Maybe that doesn't help. Put the thing in.
The last thing you want is someone with a PhD trying to figure that out, buddy.
You're probably right. Get electrocuted. But at any rate, the tube is really utterly simple, because what folks have done is one end is the switch power, and the other end, the other two pins, right, is the power grid. So if the power grid goes out, the battery backup comes into play. The lamp operates normally in a fluorescent fixture as just a regular fluorescent lamp. So a replacement. So that the TLED is just operating like the ones next to it, and figuring out.
I want you to describe to me why you think this is less complex.
Oh, your ability to retrofit this thing, it's a breeze.
No, but are you going to do every tube, or are you going to do all the tubes, or all the tubes going to be this battery powered thing, or just one in every 4?
Typically, one in every 4. Might do it, or even less. It depends on what it takes to get the minimum light level, or to exceed the minimum light level. And that's pretty easy to do with this technology. One of the tube technologies that's out there, for example, will put out about 600 lumens, okay, compared to its normal. So that's about 40% of the light output. And it lasts, I measured it lasting well over, something like twice the minimum amount of time. So there's a lot of light, okay? So let's pretend it's only 25%, okay? So if you're lighting a space at 50-foot candles, right, and you do 1 in 4, right, tubes, you divide 50 by 4, right? So what is that? That's 12. Round numbers, 12.
We need a PhD around here somewhere.
Right. Put candles, and then you take 25% of that, right? And you're still well above the 1-foot candle minimum. So 1 in 4 lamps is really easy to do.
Sure.
Really easy to do.
But let me ask you this.
If you need more light, you can always put a second one in. Yeah.
Does it know the difference between switch power, breaker off, switch off, and the power outage?
Absolutely. If the main power, the mains, right, that obviously has a breaker somewhere as well. But if you're talking about the switched load for lighting, yes, it does. It's completely separate. And this follows.
If you switch off the lights, if you switch off the lights, those lights don't stay on.
That's right. They go out. And in fact, they only come on if the power fails in the building. For example, the main.
How do they know that?
Line.
How do these tubes get so smart?
Because there is a separate power feed. And this really is basically associated with UL 940. They require that. The other thing that goes on in these tubes is that the power is completely isolated. So, for example, if you have 270 70 volts three phase, you could mix phases. In other words, you could be tapping into one phase, which is the power grid, and another phase, which was the switched line grid, and they wouldn't interfere. They're completely isolated via the circuits inside. And that's a requirement also, a UL requirement as well. So that makes for a very robust solution. The lamps also will indicate whether they're working. One of the two technologies I looked at has a little red LED that flashes every 15 seconds. And so if you look for it, you can actually see this happening. And so you know that your emergency lighting is working fine. It's working according to the specifications. This particular lamp actually has a microprocessor embedded inside the lamp. And this is important if you want to get long life. I mean, you know, you heard about cell phones and the life of iPhones and batteries and so forth. You don't want that. You want this thing to last many years. And the secret for that is to basically monitor the amount of charge in the battery, keep it at a level that really is below 100%, and do not charge the battery continuously. Charge the battery as infrequently as possible, and you'll get extremely long life out of it. All of that takes a microprocessor because you have to monitor the charge, the voltages of things, and how much you've put in, and all of that stuff. But if you do that, you can get very long lives out of it. So this is pretty exciting because this is very easy to put in. I mean, this is a very simple retrofit compared to what we've had to do in the past to ensure emergency lighting for LED systems. Typically, we'd have a backup power supply, which we'd bolt in somewhere in the ceiling. Have to go into the ceiling. Here, you don't actually have to really go into the ceiling. You have all you really need is access to the power. And if you've had an emergency system there in the past, it's there. So
yeah, what's funny about
pretty simple.
LED lighting, from my experience, is you know, I was originally selling fluorescent retrofits, and now that we've gotten to LED retrofits, Type B direct wire is very common in our market, at least. And I never cared about emergency lighting until that happened. Because once you get into that, you have to look and know, okay, do I see any red dots in the fixture? Do I see bug eyes on the wall? What do you do? That's always a question we have to ask now. So you're very right on with that. That a way we can do it easily is always welcome. You know, because it's something that we run into more often than not. We're in the middle of the job and we run into it and we find out there's emergency. Find that out up front. If I can give any advice.
Yeah, I agree. There are folks who are getting into this game, so there are things you need to look out for when you're selecting, say, a TLED tube replacement. First of all, number one is you need to have somebody who's regulatory approved, who basically meets the UL 940 requirement. Now, some folks have actually got the UL mark on their product. That's a big deal because it's fairly difficult to get that. Other folks might have an alternate mark like ETC, which is supposed to, is supposedly following the UL code requirement, but it just isn't. It isn't the same thing. And in fact, folks who have who actually come in and take a look and see if you've got indoor construction according to code really like the UL mark because they trust it. So I think, but it's important to have that. There are a host of other folks who don't have anything. You don't want to have anything to do with them. Okay. Uh, I think the second thing is really the life and safety. Okay, do you have the smarts built into this tube to be able to get the long life from the battery? And in fact, what is the battery technology? Is it nickel metal hydride, or is it lithium ion? You know, lithium is can be problematical. Samsung found out about that in their phones. Nickel metal hydride is a much more stable technology, and it works over larger temperature range. Does it have a microprocessor to be able to get this long life, or is it just trickle charging? Right.
So we're way down into the weeds with this. So there's a whole bunch of competing technologies, and battery technology is a fascinating topic, actually.
Yep.
That you could really dive into, because lithium ion is really the largest charge per weight. Right?
Yeah, the highest charge. But although nickel metal hydride comes in very close, can come in.
Yeah, you don't see power tools with NMH batteries on them anymore. It's all lithium ion now.
Right.
For weight
That's
reasons,
correct.
Right? But in a tube and a ceiling, it doesn't matter. But here's sort of my thing, Greg. Do you guys? It doesn't sound like you guys have done a lot of emergency lighting at Premier Lighting before.
We usually it's
maintenance,
on the front
testing.
end.
Like maintenance
And testing, no, not so much.
So,
replacements when needed.
Whenever I see, so the lighting industry gets broken up into sections when it gets down. So you have manufacturers. Let's say you take a traditional manufacturer. Let's take Philips in the 1990s. Okay.
Yep.
They would go and make lamps, right? And they would sell F96 T12 daylight high output to one company that would trickle it down to people that bought that tube and put it in parking garages. Okay. And that would be a customer of Greg and I's. And then they would make the same tube, and I have a point here, don't worry. And it would trickle down to another company who would put it into a sign box.
Right.
Right. And the company that sold it to the people that put it into the garage and the company that sold it to the people that put it in the sign box were completely different distribution streams, completely different distribution channels. And those two, the sign company and the lighting distributor, almost never really ran into each other that much. Sometimes a sign company would buy from a distributor, but usually they had some other arrangement where they bought something else. So you have these different things. Emergency lighting was one of those types of things where guys would buy from me. They'd come by to my office and they'd buy like thousands of 15 T6s. You know what I'm talking about, Greg? 15 T6? Candle clear, 125 watt. Yep. And they would go around and some of them would come in and I'd say, hey, why don't you buy these LEDs? He goes, LEDs? I don't want no LEDs, then I lose my job. Right? If I put LEDs in those exit signs, what am I going to do next year? Right? So anyway, they would run around with 15 T6s and 25 watts, whatevers, and blah, blah, blah. And they would go around and they would test people's emergency lighting systems once a year.
Right.
And there was tons of companies in Toronto in my market that just did that.
Yep.
Okay. So what I'm concerned about here is we have another example where different lighting, traditional lighting, go-to-market distribution channels are colliding with one another again. Okay? Mm-hmm. So now you're saying is, okay, we're going to retrofit the lights. We want to move from a exit sign bug eye based with remote head system with batteries, with lead acid batteries in these boxes that we test, to a system which incorporates the emergency lighting into the light fixture. Or in your case, Greg, you were running into those Bodine ballasts, right? Or emergency lighting ballasts that wouldn't work with bypass LED tubes. Am I correct here? Those are the scenarios, right?
Yes.
And what you're saying is that we have a tube that has a battery on it that knows when the lights are off as opposed to the building being de-energized for some reason. Correct, John?
If the building is de-energized, in other words, the lighting power grid is turned off, then the lights will come on. Yes.
Right. But if an occupancy sensor turns off the lights, or if a switch turns off, it doesn't come on. Okay. So we know that, right? So we know that's happening. You saying you can use multiple circuits and all this kind of stuff. Okay. How do they test it?
You can test it the same way.
Blinking light's not good enough, because
no, it isn't.
I'm going to want to shut it down, and I'm going to want to see the light level for the emergency lighting, and then I want to turn it back on.
You can do exactly that.
How do you do it?
You can cut the power the power to all of the lights if you want. The basic power grid.
So cut the breaker?
If it's 270 for the power distribution. That's one way to do it. Another way to do it is this lamp will allow you to have a test button. So you could basically interrupt the grid, and the light will come on, just the way it did with the way you've done it in the past. And you can mount that or use the existing one on the fluorescent fixture that you're retrofitting. So it's a power interrupt button for the on-switched power grid. So you can do both.
Hang on, I want to. Okay. Are you still on this topic? Because I want to get through this topic for myself here. So this product is built for the retrofit market, correct? This is not new construction, right?
Well, no, it could be for new construction also.
Right,
it depends.
But it's aimed at that existing building where there's a problem, where you have bug eyes and half of them are burned out, and which battery controls this and that kind of confusion.
Yeah.
So you're going to eliminate that confusion, and you're going to say, we're going to do it this way. Greg, you're going to have some serious training for your sales reps and your installation team, because I actually think this is, like, how do you tell the customer to change their procedures of testing their emergency lighting? Because I'm in the retrofit game all day, and if I can keep something the same, John, I want to keep it the same as much as possible. Now, if I go into a customer and say, okay, now we're eliminating your emergency lighting, and now your testing procedure is like this as opposed to like that, how do we go and describe that to them?
It's really the same thing, because they have test buttons, so they can test each fixture.
They have to open the fixture up to test it?
No, you can do it outside. You can have a button. The buttons typically are on the outside of the fixture.
Okay.
And you push the button, and if the lamp lights, you're good. Now, typically once a year, right, you will test the length of time, that the thing lasts. You'll test whether it works or not, maybe once a month, depend upon the local code, right?
Sure.
But once a year, you may kill that circuit and just check to make sure that after an hour and a half, the lamps are all still lit. And that's the same. So you can make it exactly.
Yeah, where I see the play for this is I run into customers that either have emergency lighting that have bug eyes on their exit sign. That's their system. You can continue on with that.
Yep.
Now, what if their fixture has a red blinking dot and you want to bypass the tubes? Your option is this, or jam something in that is emergency backup, and that's a lot more spendy than a tube situation. So I wouldn't change anything. I would say that fixture up there is emergency light. We're going to do an emergency tube in that one. Skip 2, that one is emergency tube in that one. And that's how we do it. So there would be really no procedure change from our standpoint.
Yeah, exactly. And in a hospital, for example, that has emergency lighting, typically they are in the fluorescent fixtures because they don't want to have all this extra hardware collecting germs, right? They want to be able to clean these surfaces. And this is a preferred solution in those circumstances. And in fact, from an aesthetics point of view, it's really a much preferred solution besides performance. And this would allow you to do that going forward.
You think long term the life of the LED, or the LED itself will last longer, or the battery will last longer?
Well, right now, the batteries it's typically a 5-year warranty for the tube with the batteries. And the longest life tubes are now 10 years. I think that when you see some experience with these tubes, that battery life will get extended. I think folks are being a little conservative until they get a couple of years of performance under their belts. But I think the tubes can be made to be comparable in lifetime. So this 10-year life, I think, is in the cards ultimately. Maybe not out of the gate, but if they're out of the gate, they're 5 years. So it's good.
And when you find a customer that has an existing fluorescent, let's say they have a troffer and they have 4 lamps in there, you'd want to find out how many or what their current emergency battery backup ballast does in terms of, does it turn on 2 lights? Does it turn on 1? And then you would mimic that with the correct number of tubes, I assume.
Exactly. Or it may be that you could do it with fewer tubes, depending upon how much light level they were making available in their present system. Obviously, if you could do it with fewer, why wouldn't you do it with fewer? But you're exactly right. You could do it 1 for 1 and it would be fine.
You know, I see, it's funny because I think that this solution is going to grow and grow and grow as a part of the mix. Simply because we just had a customer call us. It's getting very difficult to find these emergency lighting ballasts now, actually. I don't know. You haven't, I don't even know if Bodine is still owned by Philips now or Signify. And
yeah, Signify.
Like, I have a lot of customers that have to change those, I think, every 5 years or something like that. And they're like $150 a ballast. And I think this is going to be a major part of the mix moving forward. From my perspective, I don't know. I think it's a solution when you're using the backup fluorescent ballast. It's very obvious. I don't see it as obvious as maybe you, John, and that's okay. We're allowed to disagree.
Yeah.
To remove, like, Greg, would you go around removing people's the bug eye with the remotes if you didn't have to? I'm not sure.
I don't think I would at this point. No, I mean, if they requested it or maybe they weren't, I guess who comes around and measures and ensures their foot candle levels are being met? Do they get fined if they're not? Is there I think it's the fire department that does it, right?
Yeah, the fire department would do it. Yeah, they would in principle, right, force them to come back into code, but that doesn't always happen. You're right. But there would be they do have an enforcement capability.
Okay.
Interesting. Okay. John, fascinating. We've another technology to think through now as we're out in the field, us lighting dorks, running around selling light bulbs all day. But you know what? It's interesting because I really think that, again, it's a collision of different types of lighting companies where different distributors and contractors are now going after signs, and sign guys are going after regular lighting systems. And now all these emergency lighting guys are going to be part of the mix in terms of being disrupted as well. I think it's serious disruption here.
It's probably right. It's probably right. LED is just a short word for disruption.
For sure. And I think that's a good place to call it here, John. Hey, thank you for being a guest on the Get a Grip on Lighting podcast. Fascinating to hear about. Can you want to throw your website out there for the listeners that are listening to this? We'll also link to it on the page and all that, but go ahead and throw it out there.
Sure. www.energyfocus.com.
Always a pleasure, Dr. John Davenport. Thank you for coming on the show.
All right. Take care. Have a good day. Bye.
You too.
Energyfocus.com, Greg. Do I have to spell it?
I don't think so. It sounds, how you say it is how it's spelled.
We're here to talk about their Red Cap, Energy Focus Red Cap, emergency backup LED tubes, battery powered, easy for a retrofit, Greggy.
Yeah, every non-residential facility needs to have emergency lighting, and a lot of them might have the bug eyes, but a lot also have.
You don't have bug eyes in your house?
I don't have them in my house.
No exit signs in your house.
I should get one. Yeah, I don't have that yet. So non-residential needs it, and a lot of times, though, they are in the fixture itself. They're built into the fixture. You see a red blinking dot or a little red dot.
Sure.
That used to be scary for me when I was trying to do a Type B LED retrofit. And it was scary up until this came out, the Red Cap. Now I can say, awesome, we can do a Type B retrofit still, and we can make it emergency. We can keep you in compliance, which is important to do. They want to be able to see in case of an emergency, and this allows them to do that. It's first classified UL tube on the market for this category. It's patented. It's type B, as we said, 150 lumens per watt. Works as a standard tube when you need it to for your everyday lighting, and then emergency it kicks on. Awesome product. I'm excited about it. I'm definitely going to use it.
Energy Focus is the leader again. They started off with their flicker-free stuff. Now they're into this. They're leading the way. It's good to have them on the show. And Dr. Davenport, always a pleasure to talk to you. And it's funny about emergency lighting, the collision of different types of lighting people out there. I think emergency lighting is a great way to make money. I think also the idea of presenting someone a proposal, if they have emergency lighting ballast in those fixtures, those bad boys are really expensive now and hard to get. So guess what, folks? I would put that in. Like, I don't normally put in labor avoidance and maintenance costs, but in this case, I think it's worth it because those ballasts are hundreds of bucks each sometimes, man.
For sure.
Go to energyfocus.com. National Association of Innovative Lighting Distributors. Enough's enough. It's time for you to join. If you're listening to this and you're not a member of NAIL, stop listening. You're not allowed to listen anymore. You got to join NAIL from now on. We're going to close it all off. You got to be a NAIL member. No, of course, I'm just kidding, folks. But check us out at NAILD.org, NAIL.org. And, of course, Dr. John Davenport, the Patent King. Thank you for coming on the show again and for supporting this podcast. I love interviewing the scientists, Greg.
Yeah, it's always fun to hear it from their perspective because we don't deal with it every day. I'm not a scientist. I want to hear what he has to say.
You're the scientist. I don't know, but a scientist.
Yeah, sure.
Especially when you get that vodka going with those with the Clamato juice and that, you can be a real scientist.
That's a chemist, isn't it? Or mixologist, whatever it's called. We'll go scientist.
Go scientist. Folks, thanks for listening. Check us out on social media. We love you. Bye for now.
Written on the rectory wall, there's a sign there for all. You are lost, Lord is there to find you.